Welcome to Electronics and Software channel. Today our topic is resistors in parallel. So by Ohm's law we know that V is equal to I square R, and the related formulas are I is equal to V square over R, and total power is P is equal to V into I, and power dissipation in term of current is I square into R, and in terms of voltage is V square over R. So if we have the resistors value are same, so RT total resistance we can find by the value of resistor divided by the number of resistor in circuit. So we have the value of resistor is 100R, and uh, number of resistors are 2. So the total uh, resistance in resistance of this circuit is 50 ohm. So in parallel circuit, the voltage across each resistor will be same as of the source voltage. So we have, if we have this 12 volt, so across this 100R and across this 100R, here the voltage will be 12 volt, and also the voltage will be 12 volt across this resistor R2. So total current of the circuit is IT is equal to Vs or RT. So we know that Vs, our source voltage, is 12 volt, and RT is 50 ohm. So IT will be equal to 240 milliampere, and the total current is divided in parallel resistors. So I1 is equal to 12 volt divided by 100 ohm. So I1 will be equal to 120 milliampere. We know that both resistors are same value, so I2 will also be 120 milliampere. So IT will be equal to 1 I1 plus I2. So IT will be equal to, total current will be equal to by this 240 milliampere. It means when same value resistor current in each resistor can be found by the rules I1 equal to I2 equal to IT divided by number of resistors. So total current is 240 milliampere, and number of resistors are 2. So we can find 240 divided by number of resistors is 2, 120 milliampere. So in each resistor the current is flowing 120 milliampere. So power dissipation in this circuit we can find by PD equal to, we know that the total current is 240 milliampere. So 240 milliampere square into 50 ohm. So power dissipation will be equal to 2.88 watt total power dissipation, and power dissipation of individual resistor is 120 milliampere. So this is 1.44 watt of resistor 1 and 1.44 watt of resistor 2. So both resistors are of the same values. PD of each resistor will also be the same. Now circuit with different value resistors, if we have R1 is 100 R and R2 is 200 ohm. So by this formula we have 1 over RT, 1 over R1 plus 1 over R2, or RT equal to, by this formula we have 66.66 ohm, the total resistor, the total resistance of uh, this parallel circuit. The total resistance will be less than the lowest resistor if any. For example, here RT is 66.66, which is less than the 100 ohm. So we know that in parallel circuits the total resistance is less than uh, the lowest resistor in parallel circuits. For example, here the lowest resistor is 100 ohm, so the total resistance will be less than this one. this 100 ohm. So this is the universal formula for parallel circuits. Now circuit with different value resistors, if, so IT, we can find total current is 180 milliampere by this formula, and current in individual resistor can be found by current dividing formula. So current dividing formula is I1. So opposite resistor divided by uh, R1 plus R2 and 2 total current. So we have I1 equal to 120 milliampere and I2 is 60 milliampere. So total power dissipation uh, in total power dissipation of this circuit will be 180 milliampere square into total resistance. So power dissipation will be 2.15 watt, and power dissipation of individual resistors, we can find power dissipation of resistance of resistor 1 is 1.44 watt and resistor 2 is 720 milliwatt. So power dissipation in terms of voltage we can find by V square or R. So here is 1.44 watt and here is 720 milliwatt PD2. This is PD2 basically. So now we can check this in Proteus. So this is the circuit uh, I have made. So first we have, if we have 100R and this is 100R, so we can check if we simulate this. So here 120 milliampere the current is flowing in this resistor and 120 milliampere in this resistor. So the total voltage, if this is the source voltage and this is 100R across 100R resistor, this is 12 volt and here is 12 volt, and uh, total uh, uh, power dissipation of this resistor and this resistor, this is 1.44 or 1.43 watt and this is 1.43 watt we have found in uh, our presentation. So uh, this is the same value resistor. If we change R2 to 200 ohm, if we simulate this, so this is 1.44 watt and this is 720 milliwatt, and this is 120 milliampere current is flowing in this, and 60 milliampere current is flowing in this resistor, and resistor voltage across this resistor and this resistor is same, because in parallel circuits the resistors are uh, the voltage across each resistor is same. So this is all about resistors in parallel.